The last method to solve particular solutions we will introduce is called the variation of parameters. Okay, method 3 is variation of parameters. And it's similar as what we introduced for higher order ODE before, but now it's just using matrix representation form. So we are still trying to solve y prime equals to ay plus g. Then you know the YH is your homogeneous solutions, which you solve this y prime equals to ay. Then you can get this is ICIYN. That is combination of all the linear independent solution. So you can either write in a model matrix times Z, or you can also write as a YC form, where this will be Y1, Y2, yn. For each yi will be equals to xi, that is your eigenvectors, times e to the lambda I t, okay, times C1, C2, Cn. So that is the constant. And you can write as yc. So y is represented by your eigenvectors and your eigenvalues. The c is the constant, arbitrary constant. Okay. Then the yp is your particular solution, will be UIYI. So you use substitution to represent your particular solution. The UI will be some function of x. Then you can write as YU. Okay, that is the variation of parameters. You assume that the particular solution will look like this function times the u, which is as function of x. Then you can get the yp prime will be y prime u plus y u prime. Okay, and yp prime is also equals to a y. So ay plus g, and y is equals to yu. Okay, so ayu plus g. Okay, then since ay, you know that y prime equals to ay. Okay, since y prime equals to ay, then you can get yp prime equals to y prime u plus g. Okay, then this equation 1 here, equation 2 here, they are equals to each other. So that y prime u plus y u prime equals to y prime u plus g. Then this first term are equal to each other. Y u prime will be equals to g. Then what is u prime? U prime will be equals to y inverse g. So both left and right hand side, you times the inverse matrices of y. Then you can get u prime. How you can calculate ut? Ut will be equals to the integral of this part, which is y inverse g dt plus some constant matrices. Okay, and this yt in the end will be y times u, right? So y times u, and that will be y times the integral y inverse g dt plus yc, where this yc is your homogeneous solution. This part will be your particular solution. In general, this whole equation will be your general solution. So here, if you see is equals to 0, that only leads to the particular solution. So basically, if you don't involve this constant part, it will be particular solution. If you involve this constant part, it will be the general solution. Okay, so that is how we solve the variation of parameter method to solve the particular solution or the general solutions.